Hello, everyone. Welcome to this webinar hosted by Acumen Aviation today, and we would really, we are very thankful for all the audience today. My name is Amey Gore, and I'll be hosting the webinar today. I work as a SVP Technical and Asset Management in Acumen Aviation, and I'm also leading the team which develops high-value digital platforms for Acumen and its clients. Today's webinar is about aviation data management and the use of artificial intelligence and machine learning. In this webinar, we will be talking about the expanding use of artificial intelligence and machine learning in the aviation domain, as well as introduce you to Sparta, which is the Acumen Asset Management tool. A few housekeeping items today. You will see Ask a Question pod on the right-hand side of your screen. During the session, you can ask the questions, which I will circle back at the end of the presentation to answer. The presentation is expected to be about 20 to 30 minutes in duration, and thereafter I will answer the questions one by one. In case there are any questions unanswered at the end of the session, I have your email IDs and I will send responses on the emails for the same. A few other things to talk about. I will be using or displaying certain use cases for the use of artificial intelligence and machine learning, and also walk you through the various categories of machine learning and artificial intelligence techniques. So without any further delay, I will begin. Today, we are witnessing a data revolution of sorts, and we are looking at data as the most important utility for organizations and individuals. The availability of data and the proper management of data allows individuals and organizations to manage the risk and also cover themselves against any unforeseen events. However, as we are witnessing today, the data size is increasing exponentially, and the manpower alone cannot cater to this size increase. In fact, I recently read somewhere that there is, by end of 2020, there will be 40 trillion gigabytes of data on the internet cloud, and 90% of that data will be created in the last 2 years. Another interesting fact is that 97.2% of organizations today are investing in big data and artificial intelligence. However, due to the size increase, we are also witnessing another problem, which is managing the data properly. The quality of the output is heavily dependent on the size of the data as well as the quality of the input data being fed into the system. The larger problem today is how do we make data management processes simpler, faster, and better. As we are witnessing the data size increase, we are also witnessing the inferior quality of data being fed into the system. The answer to this problem lies in collaboration of human intelligence and technology and automating the processes wherever possible to deliver faster and better results. Artificial intelligence is a way of making the computers and systems capable of imitating human actions at a much faster rate than their human counterparts. AI is actually an umbrella system capable of including the machine learning and deep learning techniques. Machine learning and deep learning are the core elements without which intelligence in the systems cannot be achieved. Without machine learning capabilities, artificial intelligence cannot be achieved, and it translates only into process automation. Machine learning can be divided into three broad categories: supervised learning, reinforcement learning, and unsupervised learning. Supervised learning is essentially a system in which there are predefined set of rules on which the machine learning model works. Imagine the example of a face ID recognition or a fingerprint verification against a government database. This is a very typical example of supervised learning where the image captured on the camera or the fingerprint machine is validated against a database using preset rules and match points. Now, reinforcement learning is actually a step above supervised learning, and it involves a system which uses preset rules as well as the continuous monitoring of the data to form a map or a routine of the user's activities. An example of this is how Google Maps sends you a notification ahead of your daily commute to work. The way Google Maps does this is that it identifies a pattern of your daily commute to work, the time of your commute, the route that you take, and the speed at which you drive to actually identify a pattern and deliver a better solution to your commute to work. It can also provide you a better route to take in case of the traffic and accounting for the factors involved in the commute. Unsupervised learning is the most complex form of machine learning techniques out there. Unsupervised learning combines reinforcement learning and also the ability to capture data from various data points as well as various sources. An example of this is the expanding use of advertisements or unsolicited emails of products to users. Imagine a situation where you have been looking on the internet for club membership near your home, and the next thing you know, you start getting emails about fitness products or fitness apparel and all such associated product lines. This is essentially delivered through artificial intelligence programs embedded in the internet browsers and then using your browsing history or cookies to deliver the advertisements to the end user. Unsupervised learning in the aviation domain, especially the technical domain, is slightly more challenging compared to other market segments. The reason is that the natural language processing techniques, which uses specific terminologies and vocabulary, is not achievable in the aviation technical domains. The reason is that the aviation terminologies do not align with the regular English diction or vocabulary being used in most natural language processing platforms. The second reason for the challenge of using unsupervised learning is that the data sharing and IP cannot be translated or shared across platforms. This is the reason that unsupervised learning cannot be directly delivered in the aviation technical domain. Now, are we able to say today that human intelligence or genius can be equivalent or surpassed by machines? We certainly don't feel so, as we are not there yet. However, the collaboration of people and well laid out processes supported by the appropriate technology can make organizations ready for the future as well as maintain their competitive advantage. In our experience of implementing successful AI platforms, we have come to realize that the data size or the models being applied are not as important as the depth of the data and the methods applied for cleaning the data to harness the relevant data points. The depth of the data and the relevant data points is the most essential element which drives the machine learning model towards the desired goal. Here, I would like to introduce you to Sparta, which is our asset management platform. Sparta was designed and developed 2 years back as a primary project management tool within Acumen as a supplementary product to its services. However, we have remodeled the platform subsequently in the last 2 years to make it an integrated modular system and also enhanced its capabilities by introducing artificial intelligence and machine learning models. The typical use cases that we looked at were contracts built up in the system or identification and segregation of records, as well as reviewing regulatory requirements, all of which are extremely time consuming and require a high value result at the end of the review. The contracts module is typically enhanced by using natural language processing to build up the assets contract in the system. Most of you who have used legacy ERP systems will know that setting up an asset or its contract in a ERP system can typically take several days at times, depending on the complexity of the lease agreement and the data points to be extracted. A user, in this case, has to manually read through the lease agreement, extract the relevant data points, and then populate the system with those data points in a manual effort. In Sparta, we have automated this system by allowing the user to upload the lease agreement into the system, and the natural language processing model will read through the lease agreement, extract the relevant data points, and populate the fields in the contract module. After rigorous testing of this module and deploying it in the production environment, we can certainly say that the effort now is less than 12 hours to populate the necessary fields in the system. Coming to the use case of identifying and segregating records using machine learning, this is another model which we saw as a definite value add in the asset management system. Imagine your weekly laundry chore in which you drop the laundry bag full of clothes at the nearest laundry service center. At the end of the service, the customer gets all their clothing neatly separated out, folded and delivered in the respective bags. In a comparable example in technical records, the complexity is much more and the task is much more laborious. So we have identified this use case and applied the machine learning model here to deliver a far superior and faster results. The user can upload all the records into a folder on Sparta, and the machine learning model will identify and rename those files as well as segregate them into their respective folders. During our testing, we have observed that almost 1 gigabyte of data or more than 1,000 files can be segregated, renamed and populated in their respective folders in a span of close to 24 hours. Finally, the third use case is about reviewing the regulatory authority requirements or airworthiness directives using natural language processing and a technique called web scraping. I'm sure that if anybody in this aviation domain has gone through the EASA or FAA website for downloading ADs, it is a very time-consuming task and also requires a keen eye to go through all the ADs listed on the operator's AD status against the EASA or FAA database. In Sparta, we have modified this problem into a solution by using web scraping, whereby a script of code sends a command for the system to visit the EASA and FAA website to download the applicable ADs on a regular basis and create a database. When the user uploads the operator AD status into the system can validate the AD report against the database and give the results in a matter of minutes. The high-level review delivers the user with a list of ADs which were not included in the AD report, as well as provides a link to the applicable ADs for an easy review. Coming to the point of robotic process automation or RPA, it is essentially a process automation technique which is devoid of any intelligence. However, it is a unique feature in Sparta which delivers faster results on tasks which are extremely time consuming, as well as delivers a better user experience. We have identified areas in the records review processes which can be automated by improving the user experience and providing the user with the necessary tools to perform the review faster. We can use these RPAs for performing a segregation and rename of release certificates for aircraft components. We have also delivered automation in the technical specification updates in the system, and we are also looking at collating and producing marketing data packs or engineering data packs based on the records available in the system. These are the typical RPAs that we have already identified and modeled already. However, there will be more features to come in the system in the coming days. We are extremely focused on using technology and artificial intelligence as well as machine learning models to improve the Sparta product as well as provide better efficiency for our customers and end users. With that being said, what are the key takeaways from this webinar today? First one, of course, data is at the center of everything today. We all need data to provide for better results and efficiency in our operations. However, bigger the data doesn't mean good data. The data cleanup process is an extremely crucial and valuable step in using machine learning or artificial intelligence models in our operations. Finally, data-driven decisions are always better in terms of delivering better results, and also data-driven decisions offer a better foresight for companies to warrant against future risks. With that being said, we come to the end of this presentation. You can always contact myself or Preetham for any questions outside of this presentation. However, I will open the forum now for any questions that you may have.